Okay, guys, now what we're going to do now is I actually wanted to show you a couple of things about the way this chart works. I want you to notice that this is, if you actually click on any of these little dots, it'll actually tell you if you have a linear line or if you have an exponential line. Now, what you notice is it's kind of a nice curve. This curve would actually probably fit a little bit better if you didn't have these outliers. It would also draw a much better curve if you didn't have the data, if you had more data. So what we're going to do is we're actually going to go back to these form responses that we got. Now what I'm going to do is I'm actually going to use everybody's data. Now you notice that I've cleaned up the data for you. There's a reason for that. It would take you guys way too long to clean up on your own. So I'm just going to leave it cleaned up. What I'm going to do is I'm going to copy this. And we're going to actually go to Boyle's Law 2, and I'm going to paste it right here. Now, first thing you notice is we do still have some other data there that's not very clean. We have to get rid of that atmosphere. So the way you do it is you go Control F, and that actually brings up the find box, and I'm going to type in ATM for atmosphere because that seems to be the label that they put in. I'm going to click on these three little dots, and I'm going to say, here, let's replace all those things with nothing. And then done. Now you notice all these are gone. You'll notice it actually right here, Tim, we put down Kelvin, temperature, we're supposed to put down pressure. That's okay, we'll just take that out. So I want to just actually try one other thing too. I actually want to see what happens if we do this data just based on length, okay? Actually, what we're going to do is we're going to insert a column. We're going to insert one column to the left. Hopefully we got everything. There we go, we got everything. And now what I'm going to do is I'm actually going to calculate volume. And the way I do volume, of course, I already decided this is a square container. All right, it's a perfect cube. And it's 6. It equals, so we need to put in a formula, so it's going to be equals 6.6 times 6.6. I'm telling you that's the height and the width of it. And then you're going to just multiply it by the length, which can vary. And that's going to affect the volume. Boom. Okay, so this is 331 cubic centimeters. And the other thing I'm going to do, just so we don't have a huge amount of decimals, I'm going to format this. Actually, I'm going to go click on this, and it says format, number. I'm just going to have it with, actually, only want 2 decimals. There we go. And I'm just going to drag this all the way down to the bottom. Make sure you get all the way to the bottom. I made that mistake. Boom. Beautiful. Now everything looks pretty good. But I noticed something that's a little weird. I mean, all these size numbers seem to be kind of like together. Everything's kind of normal. All right? But if we actually sort the pressure, well, actually, let's just do this to start off with. We'll just try graphing this because I think you're going to notice the problem. If you highlight these 2 rows and hit graph and say, I want to put in a scatter graph, you click this one, and you'll notice that I got like this, what appears to be a slightly curved line over here. And then I've got this weird kind of, these few data points that are off to the side. And there's the one that's at 300 with it, the one with the 210. All these numbers are like really much higher than these other numbers. So I'm just going to cancel this. And I'm going to sort the pressure column. So I'm going to go data, sort column C, A to Z. And you notice that all the pressures are like 0.75 atmospheres, 0.79 atmospheres, okay. 0.9 atmosphere, 1 atmosphere, all this all kind of makes sense. All right, you're going to notice that we still are missing some things here. I'm going to click. I'm not sure why these guys disappeared on me. It looks like we're getting a lot of extra data points, but as you scroll all the way down, I'm not 100% sure what happened, but you'll notice that suddenly you go to much higher size. Okay, all of these numbers here are wrong. 8 could be right, but 73, all of these other numbers here are wrong. Okay, I'm not sure where these came from, but obviously these pressures are too high. So what I'm going to do is I'm going to skip and I'm going to scroll. I'm just going to go pressure and volume. I'm going to scroll all the way up to the top. Okay, I'm only picking, and I really need to do that again because I did that too quick. I'm only going to pick these guys from 8 all the way up. Okay, so down here, you notice the numbers are all pretty good up until we get to this point where they get kind of wacky. You know, 8, we go from 8 to 73. That seems wrong. I'm going to scroll all the way up to the top. And I'm going to go graph. And we're going to go chart. And we're going to go scatter graph. And you notice that it does look an awful lot more like a curve. Again, we still have a couple of screwed up data points here. I'm not sure why they're there. But the bottom line is it looks like the majority of people have good numbers. So now all I have to do is say what's going on. Okay. The horizontal axis looks like pressure, and the vertical axis is volume. So I'm going to customize this. This is class data, Boyle's law. State of Boyle's law. Alright, and I'm going to go down here. The horizontal axis is pressure in atmospheres. And vertical data is going to be volume in centimeters. Cubic centimeters cc's. Okay? And then go insert, and then we get our graph. Now, the one other, you can also move the graph where it needs to be. And then one other thing you can do now, if you actually take this, and you draw an exponential curve, and draw a nice curve, you'll draw a nice curved line. Right? Actually, that curved line really shouldn't, this is what's called a limit. The curved line actually shouldn't hit the x-axis. It should just curve straight up. Right? So that's basically what this, that's actually a little bit out of line. Let's just go with the exponential curve, and that gives you a little bit of what it's supposed to look like. If you actually take a look at the curve, what it really does, it actually looks like it goes into at pressure, the pressure becomes, if you have a huge volume, the pressure becomes infinitely low. Okay? If you have very, very small volume, the pressure gets very, 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 very high. All right. So anyway, so that's what's going on here. That's how you do the class data. All right. So there's a little bit of, so next thing we're going to do is we're going to actually work on creating the other graphs. We're going to enter our great data for Boyle's, Charles's law and Gay-Lussac's law.